before we have Lavu begin her presentation, we'll just play the short intro from Thapani, who unfortunately was unable to join us today, but she did record this intro for Lavu.
Hello everyone, my name is Thapani and this is my second year volunteering with Magic. This year, I had the pleasure of working with Lavu. Over the past few months, she's been working extremely hard on brushing up her programming skills with Python. I also introduced her to the data science workflow, and we both explored bioinformatics together because that is also new to me. Lavu, I just want to say I am incredibly proud of you. I know that, these past few months must have been extremely challenging since you just had to learn a lot of new things, but I am sure you will do fine, great in the future because you're bright and talented. I will definitely miss our chit chats, so please keep in touch. Without further ado, I'm super excited for Lavu to share the machine learning algorithm that we built together. Hello everyone, my name is
All right, Lavu, so if you want to go ahead and take it away, just remember to let Ira know that you're ready for the next slide by saying next.
Hi everyone, I'm Lavu B, and I am a freshman at Menlo School. Next slide, please. So my mentor is Thapani, and she is an application developer at the University of South Florida. And she majored in political science and minored in the Chinese language. And Thapani enjoys weightlifting, cleaning, reading personal development books, and watching Asian dramas. Next slide, please. So the project that I ultimately chose was drug discovery using machine learning for Alzheimer's disease, where I basically built a machine learning algorithm that can be used to discover drugs that treat diseases. And like I said, the disease I chose to focus on was Alzheimer's disease. So I basically looked at different chemical compounds and tried to find which one actually showed activity towards the disease, so whether it was reactive or not. Next slide, please. So why I selected my project. Ever since I was introduced to biology in 6th grade, even though it wasn't really that in-depth, I became really interested in the subject and started doing some more research on my own. And then later that year, COVID hit. And then I kind of got interested more in how vaccines work and kind of got introduced to that and became interested in other medications and drugs as well. And I've also taken other computer science courses, and I'm currently taking computer science in school. So I chose this project because it kind of ties in all of these different interests. So my magical experience has been really great. And some highlights are learning about the data science workflow and bioinformatics, which are both fields that I really didn't know much about. So it's been really cool to learn about them, as well as kind of expanding my knowledge in coding, especially in Python. And it's been really, really cool seeing how machine learning was applied to the real world with drug discovery, as well as just the different steps there are in building machine learning model. Was really, really interesting because I really knew nothing about machine learning before this. One lesson that I learned was to really use my resources well, especially because oftentimes whenever I was stuck on a coding issue or just something that I really didn't understand, it could be very frustrating and overwhelming. So I really had to learn how to break down the problem, even just use Google and the internet, or just reach out for help. And this kind of ties into my main challenge, which was that there was just a lot of information to digest and could be very confusing at times. So I really had to learn how to use my resources well. Next slide. So some topics that I learned were data science and bioinformatics, like I said, and the different steps there are in analyzing data. And some technology I learned are Python, using Google Cloud Notebook, which is what I use for my project, and storing my project in GitHub. And in terms of my progress and project timeline, For the first month, I kind of spent brushing up my skills in Python for the first month. In a little bit, I'll be showing you one of the first programs that I made. And then I also got an introduction to the fields of data science and bioinformatics. And then lastly, I built a machine learning model for drug discovery. And in the future, I really want to create another drug discovery model for like another disease. I think that would be really cool. So something like COVID-19, maybe. Yeah. So this was one of the first programs I made. It's a pretty simple calculator program where basically the algorithm takes in what operation the user would like to use. So either like addition, subtraction, multiplication, division, or exponents. So I, as the user, chose exponents, and then the user enters a first number and a second number. It'll print the result, which is 4 to the power of 3, which is 64. So next, I'll kind of be introducing some of the topics that I learned. And one of those topics was data science, which is a field that allows you to gather insights from data that you have or have collected. And some common tasks for data science are exploration, where you explore data to gain new insights, inference, where you apply statistics to draw conclusions. And an example of this is if a company wanted to learn more about its customers' needs and wanted to create a product that was better suited for their needs. And also prediction, where you could use machine learning to make predictions on new data. And an example of this is if you wanted to classify whether an email was spam or not, you might use a machine learning algorithm to do that. And on the picture to the right is kind of a picture depicting the data science workflow. And the first step that's really important that is actually not shown in the picture is to come up with like a question or like a problem you're trying to dig deeper into. And once you have that, you want to collect your data from a source. And then you want to prepare your data and really clean it up, because oftentimes raw data is like very messy and has like a lot of redundant information. So you want to like clean all that up. And then kind of explore the data and identify like patterns and trends within the data. So you might use like mean, median, and mode for that, for example. And then for the last 2 steps, analyzing and visualizing, it really depends on like what your end goal is. So for example, if your goal is to inform a company more on what its consumers are doing or interested in, you might create a dashboard. Or if your goal is to recommend products to consumers and increase your sales, you might create a model. So yeah. Another topic I learned is bioinformatics, which is basically a field where you're trying to make sense of biological data using computer science and biology. And in my case, I was trying to find what drugs can be used to treat Alzheimer's disease. So kind of getting into my actual project, which just as a reminder is drug discovery with machine learning for Alzheimer's disease. Just for some context for where I got my data from, the data sets I used for my project came from the Chembl website, and Chembl is a chemical database of bioactive molecules. Next slide. So this is one of the data sets I used for my project. And as you can see, all the different rows are basically different chemical compounds. And all of the different columns are basically like different qualities. So for example, the bioactivity class is whether it's active or inactive. MW, which stands for molecular weight, is basically like size. Log P is solubility. And all the way to the right is my target variable, which is PIC50, which is really important because that's what's ultimately going to be helping me figure out like the potency or like effectiveness of the compounds. So I performed exploratory data analysis, which is basically an analysis approach that identifies general patterns in data. And these are 2 things I wanted to highlight. So on the left is a frequency plot where you have inactive and active molecules. And as you can see, there are a lot more inactive molecules than active molecules. And this is an important pattern to distinguish because you generally want to have like a good distribution of different types of data because you don't want your model to be like biased. And on the right is another graph showing the PIC 50 values of inactive and active molecules. And like I said earlier, this is also really important because the PIC 50 values are what tell you the effectiveness of the compounds. Okay, so lastly, I built a simple model using random forest regression, which is a tree-based algorithm. And the model basically took in qualities of each chemical compound and tried to predict the PIC 50 values. And the graph shows the actual versus the predicted values. And since the line and dots are closer together, the accuracy of the model was better than just random guessing. So it's a pretty accurate model. So yeah, I think that wraps up my presentation.
All right, wonderful, Lavu. Thank you so much. Do we have any questions from the audience?
I think Ms. Harding, you're in mute, I think.
How's that?
We can hear you now.
Oh, I would just like to ask, was there a reason you chose Alzheimer's as your area of interest in terms of the data, or what was behind that choice?
There wasn't, I guess, a specific reason I chose Alzheimer's. I was just kind of looking at like different data, and I just decided to choose Alzheimer's. I guess I was just more focused on like the process itself of like building a machine learning model to kind of discover like the effectiveness of drugs. So yeah.
Wonderful, thank you. Is there another question from the audience?
I have a question, Smriti here again. This was really cool, and thank you for walking us through the data science workflow. And I think I also work in the field of ML, and looking at data can be so important, and especially that exploration you talked about. And you noticed this bias with inactive and active. I was wondering if you talked about how you can correct those biases. What are the methods that you could do to fix that?
Well, I guess it's kind of like similar to like cleaning up data where you kind of have to like create a program and just like, for example, before like there were inactive and active molecules, there's also something called intermediate, and you basically have to like come up with a program to also reduce like that like class, just so that it's just more like easier to deal with your algorithm. Yeah.
Right. Very cool. Thank you.
I have no question, but I did want to say very impressive. I mean, I cannot imagine ninth graders having this kind of understanding. You know, Smriti is a professional. She's been out of school for 3-4 years. And it's amazing how you can even explain those concepts. Thank you so much. Amazing work. And thank you to Thapani, who's not here right now, but yeah.
All right.